Okay, good evening. Let me show to you my screen. Okay, so we'll continue our review session. We are going to continue area moment methods. You have three moment equation and influence lines. Okay, so let us have this first problem. Let me read. The simple beam AB having a span of 3 meters supports a concentrated load of 300 Newton at 2 meters from the left support. Are asked to compute the deviation of B with respect to tangent at A. Are going to compute the deflection at a point 1 meter from left support and then compute the maximum deflection of the beam. Okay, so let me use this one. Okay, so based on the problem, as you can see, we have here a simple beam, 3 meters in span. You have, let's say here is A, and then you have here B. You have a concentrated load of 300 kilonewton, and a distance 2 meters from the left support. So we are going to compute the deviation first at B with respect to tangent at A. If we're going to draw here the elastic curve, so elastic curve looks like this. So if we're going to draw the tangent line from here, so this is the question that are being asked. Deviation at B coming from A. Deviation at B coming from A. So this is the first question. So how are we going to do that? So we draw the moment diagram. Okay. We draw the moment diagram. So we make our reference from here. Can use from here, I think. So if we have, okay, let's consider first the reaction A. Let's say you have here reaction or RA. The force will be going, if we take moment here at B, so it could be like this one. Again. It's let's assume this is a straight line, okay? So this is RA times the total distance is 3. So this is 3 RA. Okay. Now, how about this 300 kilonewton? This one. Well, let's also have this coming from here. So this is just 300 times 1 is 300, of course. Okay, 300 kilonewton meter. It's a moment, so it's kilonewton and meter. Now we compute the deviation at B from a line drawn tangent at point A. So how are we going to calculate this one? This is first question, okay? Deviation at B from A is just equal 1 over EI. The area moment diagram, okay, or area moment diagram from A to B, and then centroid coming from B. So area moment diagram times centroid, area moment diagram that is from B to A or BA. And then centroid, since we are taking this B at B, deviation at B, centroid coming from B. Okay, so let us compute. So what's the area? This is this area of the triangle, this one. Okay, this is just the area of the triangle. This is 1/2. Okay, 1/2 times 3RA, 3RA times the base. Okay, the base is 3. Oh, wait, I'll check if I'm recording. Okay. And then the centroid. What's the centroid? Coming from here. This is 3. Centroid, obviously, is coming from here. Here, maybe you can use this one. From here, the centroid going here. What's the center of the triangle? Is just 1/3 of that base. So this is 1/3 of 3. 1/3 of 3, obviously this is equal to 1. So this is 1. That is just the upper area moment. Then you have next minus, this one's negative. Still the area of the triangle, 1/2 times this side is 300. Okay. Times this side is this one is 1 meter times what's the centroid coming from here? So let's say centroid is here over here, going here. This one should be 1/3 of what is this length? This is 1. Okay, so this one is 1/3 of 1. Okay, 1/3 of 1. So we can compute here deviation. If we calculate this one, you have deviation at B from A. Deviation at B from A equals to, of course, this one should be divided all by EI. You can check it. It's equal to 400 EI. Okay, 400 over EI. So that is the dimension of the deviation at B coming from A. Okay, this is the side. That's the first question. Okay, what's the second question? Compute the deflection at the point 1 meter from the left support. So where's that 1 meter from the left support? 1 meter from the left support. Here's the support coming from here. It's 1 meter. If this is 2 meter, this one should be 1 meter. This area is we're going to compute the deviation. Let's say you have this one. Okay. If this is 1, this distance is 1. Here, over here is 1. So this height is just equal to RA times 1 or equal to RA. Okay. So if we're going to get this, this is our deviation. Let's say this one is, could name a point C. This is point C. In other words, this one, deviation at C coming from A, coming from here. So we can compute deviation at C coming from A, and then we have this one as our Y. So we can have later the ratio and proportion of this triangle. Okay, this triangle is similar to this big triangle. Okay, so let us compute this. Let us compute this deviation C from A. Division at C from A. So we're just going to get this area. What would be this area? This is RA, 1/2 RA times, this distance is 1. This distance is 1. Okay, so you have here deviation at C from A is equal to, this triangle is just like this, okay? This one, I could put it here from, so this is RA, okay, this is 1. So the area of that one, the area is simply equal to 1/2, okay, RA times 1. And then the centroid from here, the centroid coming from here is just 1/3 of 1. So you have here 1/3 of 1, or just equal to 1/3. Okay. So what's this value? Equals to RA over 6. Okay, am I right? RA over 6, or I haven't shown you why it becomes 100. The RA here is equal to, I forgot to show you the calculation for RA. Obviously, if you are going to, if we're going to compute the RA here, we take moment at B, we can compute RA. So let me show you here. So if we take moment here at B, summation moment at B is equal to 0, we can compute RA. It is just RA times, this distance is 3. And then you have, this is clockwise going here. And then this one, counterclockwise, you can just equate. This is equal to 300 times 1. So therefore, RA is equal to 100 Newton. Okay, that's why if you substitute here, if you substitute here 100, the value is 400. Okay, let us just substitute here RA is equal to 100, then we can have this equal to 400. Okay. This one, this RA is equal to 100. Okay, let's continue from here. Once we substitute here, RA is equal to 100, this becomes R is 100, 100 over 6, of course, this one all over with EI. So that becomes 100 EI. Okay, 100 over 6 EI. So how can we get the how can we get the deflection? The question is to compute for the deflection. Compute for deflection at point 1. So we're going to compute this deflection, this y a y no, this y. Okay, let me draw here the big drawing of this so you have here earlier as I draw. So this point C, this is A, this is B, this is deviation at B from A, this one is deviation at C. Take note that this deviation is measured coming from the elastic curve. This is one is the elastic curve. Then you have here the deflection Y at distance 1 meter from A. This one is 2 meters. Okay. So we can have the ratio proportion, deviation at B. Oh, we'll use black. Deviation at B from A. This side, okay, this side is to this side, the triangle, which is 3 meters. and then equal to this big triangle, okay, is proportion or similar. This big triangle is similar to this small triangle. So there's a relationship. Okay, this deviation, this side deviation at B from A is to this side 3 meters, and then this side, which is just equal to Y plus deviation at C from A all over this side, which is equal to 1. Since we have calculated this one and then this, therefore we can calculate Y. In other words, Y here is just equal to, we transpose, this is just deviation at B from A all over 3. This one transposed to the other side will become minus deviation at C from A. So, let us substitute. Earlier, we calculated deviation at B from A is given to be 400 over EI. Okay, so we have here 400, okay, over EI. Then you have here 3 multiplied by EI minus, you have minus division at C over A, which is 100 over 6 EI. Okay, so this one, deflection Y is now equal to, what is that value? If you are going to calculate, that becomes 116.67. Okay, you can check further. 116.67. This is from my calculation. You can check it better. You can check it with your calculator. It is just this one, you multiply by 2, this becomes 800 over 6. 800 minus 100 is 700, so that becomes 700 over 6. 700 divided 6 is equal to 116.67 EI. So this one is the value of your deflection at a distance 1 meter from point A. Next one is to compute the maximum deflection of the beam. How do you know the maximum deflection of the beam? I'll try it here. So from here, how do you know the maximum deflection of the beam? That is when the slope is equal to 0. Okay. So where can you find the slope here? So at a certain point, when you draw a tangent line, for let's say a horizontal line here, the slope of this one, M, is equal to 0. If the slope is 0, meaning that is the lower point of the curve, and that shows that this one is the maximum deflection. Okay, so what you need to do now is to compute the deviation. Okay, at this particular, okay, we have deviation at B and A. You have this deviation E from A. If we have this triangle for the maximum deflection, and then this one, then we can compute Y. But this distance is, of course, it's not 2 meters. It has something to do with the value of X. Okay, so if you have here, so you have here the beam. Let's say this is your beam. Okay. Okay. So this is your elastic curve. Your maximum location possibly is somewhere here. by which you don't know it, that you have to identify. This is the value of your x, and this is the original deviation before that we calculated deviation at b from a. We calculated this one equivalent to 400 over ei. If you still remember, that's yeah, it's 400. Okay, it's 400 over ei. Okay, so if this is a, this is b, and then we say this one is e, by which we are going to get this value of y, and then we have this one as deviation at e coming from a. Okay, deviation at e coming from a. So if you are going to draw again, let me just draw again the diagram. Okay, earlier we say that this one is the value for our r is 100, and then you have this one, ano, so some here is x. If this is the reaction here is equal to 100, so this should be equal to 100x. We have here, we assume that the load is coming over here. The concentrated load is coming over here, which is equal to 300. And it's coming over here that we can just neglect. So we can use this one. So what's the value of a deviation? A deviation at E coming from A. So meaning you're just to compute the area. 1 over EI of this area. Okay. This is equal to X. What's the area of this one? Of course, that is just the area of the triangle. You have 1/2. This side is 100x. 100x. Okay, multiply by this side, the base of the triangle is x. And then you need also the centroid. Okay, since this one is deviation, the centroid coming from here, going to the location where you're going to get the moment. So this is just x over 3. So you still have multiply here, x over 3. So you don't have any more other areas to include. So this just becomes 100 3x x cube over 9. Oh, no. 6. Okay. 2 times 3 is 6 EI. Okay. So that becomes you have 100 x cube 6 EI. Okay. So now we can have a similar triangle again, this one. This triangle, okay, this triangle is similar to this big triangle. So this is, let's say you, if this is E, we can have this as F. So you have, this side is EF. So EF is 2, this side which is X. And then you have this deviation B over A as 2, 3. We know that deviation B over A, okay, is just equal to 400 over EI. It's here over 3 EI. In other words, we can compute EF. So therefore, EF could be calculated equal to X 400 x 400x, we just multiply, cross multiply here, okay, over 3 EI. So you have 400x over 3 AI. And from that, from here, we can compute the value of y. Since we already have the value of this deviation at E from A, then we can compute the value of this y. Okay. Okay, so from here, we can have, let's just copy this one. Okay. So we can compute now. We can show now this relationship. This side, which we already have shown here, we already have calculated EF, so we can what's this? Compute now y. Okay, y is just equal to y. Looking at it from here, y is just equal to EF minus this deviation C from A. What is EF? We calculated earlier is 400 over, and this is 400 x over 3 EI minus what's deviation at C from A. I think we have it here. Deviation at C from A, it's 100 over 6 EI. Division at C over A, we calculated it before, it's 100 okay, 100 x squared, x cubed over 6 EI. Okay. Just to show you, this is our calculation before. Deviation at C. This one. No. This is deviation at E, I should say. E from A. This one. Division E from A. We just kinompute lang natin ng y dito. EF minus deviation at E from A, by which E from A is already 100x cubed over 6 EI. This is the one. Okay. Now, for us to calculate y, we need to get the value of x. Now, how can we draw the relationship in getting the value of x? Okay. So this one, we need to come up with this triangle. Okay. So if you have here this side, lakihan ko lang ng konti para mas madaling maintindihan. This is the elastic curve. This is the line that we draw. Okay. So we have this angle. Let's say this angle is theta. This is A, and this is this point. Okay. This is at E. This is also this angle is also theta. Okay. This is theta. Okay. This is also theta. Let me check baka may. Okay. Okay, so how can we compute this angle with respect to x, or with respect to x? So this one, you have this value of x. We already have this before, this area, so we can compute the angle here, theta. Take note that when you compute this the rotation or the angle, Just like with the deviation, you don't multiply centroid. You just multiply the area. You just compute the area. Okay? You just compute the area. So if you have ang area moment niya ganito, no? This is the area moment niya. 100x dito eh. And this is the distance x. Okay? Tama ba? 100x and this is the distance x. Okay? Ito yung area moment niya sa taas. This one. Okay? 100x and then this distance x. So, what is the angle of that one? This is from A. Ito yung corresponding, this one, ito yung corresponding area moment nitong side na may distance na x. Okay? So, AE, sabihin natin AE, this angle from A to E is just the area, okay, of the area moment. So, what is that? It's just 1 over EI, no? 1 over EI multiplied by the area of the triangle, 1/2, 100x, 1/2 100x, multiply by x. Okay? So, area lang. Pagka angle of rotation. Pero pagka deviation, ito yan, no? Pagka deviation, may additional dito na centroid. Area lang, ito lang, oh. Pagka rotation lang, ito lang. Pero pagka deviation, see this one, deviation E from A, merong centroid. Pero pagka angle lang, gaya sa ginagawa natin ngayon, wala na siyang centroid. Yung centroid na coming from here. Okay, going here. Ito yung centroid. Wala na siya. Okay, so what is this value? This is just 100x squared over 2EI. Okay, 100x squared over 2EI. Okay, or 50x squared over EI. Now, meron pang isang relationship na pwede makompute natin ito. Itong side na to. Ano? This big triangle. Oh, no. Yeah, this one. This big triangle. Itong triangle na to. Meron din relationship na makakompute natin yung angle. As you can see, ito yung gusto natin i-compute. So, the same angle, kasi yung kinompute natin ito, EA, ito yan, ano? EA. Ito naman, angle at A. Sabi natin, angle at A. Okay. What is this angle at A? Okay. It is just this deviation multiplied by X. Tama ba ako? Okay. May relationship sa plastic design na this distance, okay? This is 3. This one, this one is divided here. It is just like tangent of theta of 400 over EI over 3. But in this case, very minimal na kasi yung mga elastic curve. Minimal na siya, kaya wala na yung tangent na yan. So yung angle na yan na angle A ito. This angle A is just 400 over EI. Okay, ito yung 400 EI divided by 3. Okay, 400. And this one is just equal to angle EA, which is 50x squared over EI. Equal siya. Ano? Sa mathematics, if you have this line, this angle, x, is the same also with this angle. Ito din yan. You have this line, this tangent line drawn from A, and if you are going to cut with this line, itong pula, this angle is the same with this one. So we can have the relationship. Thus, we generate or we formulate this equation. And from here, makancel lang naman yung EI, we can compute the value of x. Okay? So it is just like 400 divided 50, then square root of it. So the value of x is 1.63. Ano? Calculate nyo na lang. 400 divided 50, then the square root. Or square root of 400 divided 50. Or square root of 8. Kasi to cancel, okay? 40 divided 5 is 8. Okay? Square root of 8. Or, calculate na natin. 8. Tama ba? 2.85. May 3 pa pala. May 3 pa pala ako dito, no? Okay. Okay. May 3 pa pala dito. It's actually 40. Okay. It's actually 40 over 5. 40 over 15. Square root of 40 over 15. So this one is square root of 40 divide 15. Tama ba? 40 divide 15. Square root. 1.63. So pagka makompute na natin yung x na 1.63, makukompute na natin yung deflection. Kasi andito na may formula na tayo. When you substitute the value of x is 1.63, then we can compute now the value of y, which is 145 over 15. 145, okay, 0.15 over EI. Okay, so ito na yung deflection, maximum deflection. Meaning the location of the maximum deflection is at distance 1.63 coming from point A. Okay, so recap lang natin konti. Ito yung first na calculation natin dito. Ito lang naman ang mas madali lang itong una. Deviation at B lang from A. Deviation at B from A. Okay. Deviation at B from A lang. Ano? And then, the second question naman, yung deviation at C from A, yung distance or deflection at 1 meter from A. Kinumpute lang natin yung deviation at C from A. Then we get this relationship. Then we're able to compute the value of Y. Ang medyo komplikado lang itong calculation ng maximum deflection. Kasi you need to come up with this relationship by which you need to compute this value of x, ano, itong value ng x, by which this slope should be 0. So ito lang yung medyo komplikado dito. Okay, any question? Nakuha niyo ba? Nakuha niyo ba? Kung may tanong, sabihin niyo lang. Okay? Anyway, pwede naman niyo i-review ulit ang video for one. Ito lang naman pinakamahirap sa mga area moment diagram. Area moment method, I should say. Pagka kino-compute or tinatanong yung maximum deflection, yung mag-formulate ka talaga ng equation na you will come up with this value of x. Okay, so we'll move. So what is one? A prop beam having a span of 20 meters. Board exam type problems in CE. Board May 1999. Okay. So a prop beam having a span of 20 meters, as you can see, carries a load which varies from 10 kilonewton meter here from the fixed and then 0 dito sa end. First, we're asked to compute the reaction at B. Ito. Obviously, sa mga question na ganito, pagka mga prop beam, pagka tinatawag na prop beam, yun yung parang cantilever siya, no? One side is fixed, but there is a support here and the other end. So, pagka tinanggal natin yung support ng B, that becomes a cantilever beam. And this kind of beam is a indeterminate type of structure. Indeterminate, no? The reactions is way more than compared to the available equilibrium equation. So, compute the reaction at B, first question. Second question is to compute the location of the maximum deflection from the propped end. And then compute the maximum deflection of the beam. Okay, parang similar din itong sinolve natin nung una. Okay. So here, ito yung reaction ito yung natin, beam. So mayroon ditong resultant load lang na it is just the area of the diagram kasi 10 dito sa fixed at 0 dito. You have distance of 20 meter. So the reaction, no, I should say, the resultant load is 1/2 of 10 times 20. Yung area lang ng triangular load. So we get this one. So 1/2 of 10 times 20 is 100. Tama, 100 kilonewton. Okay. So pag kinumpute natin, pag nag-take tayo ng moment dito sa side, R times 20, magiging 20R lang. And then dito naman, ito yung 1/2 10 times 20, multiply lang natin yung 1/3 20. Ano itong 1/3 20? Ito yung centroid. Okay? The location, the resultant force na 20 over 3. So, meron tayo dito 666.67 kilonewton meter. So, from here, ano yung tinatanong? Reaction at B. If we are going to draw, ito yung elastic curve, ano? Pagka nasa fixed, zero ang slope nito. Ibig sabihin, pag mag-draw ka ng line dito sa fixed support, yung line mo is just horizontal. Okay? So, this part, there is the deviation at B from A, meaning when you draw a line at this point by which the support is fixed, when you draw a line, and this is the line, when you draw this line, the line is horizontal. Pagka mga fixed support. Pero pagka hindi fixed support, alam ba roller, pag ganon pag mag-draw ng line ka, ganon. Okay? Pero pagka fixed, like that, ang elastic curve, gaganon muna siya. Automatic na yan na yung tangent line dito, the slope of the tangent line is equal to 0. Okay? So, in other words, the deviation at B here from A is equal to 0. Wala siyang deviation. Okay? Pero pagka kuwan siya, pagka cantilever, meron siyang deviation. Kasi pagka cantilever, ito, gaganon lang yan papunta dito. Ito yung elastic curve. Okay? So, pero pagka prop, 0 yan. And then, from here, makakapag-compute na tayo ng reaction. First, we have just to calculate this one. What is the area of this one? Ito na nga pinakita ko. 1/2, ito 1 over EI. 1 over EI. The area of this one is just 1/2, okay, 20R times this side, itong this side, which is 20. And then the centroid coming from here, dito, pagka mula dito is 1/3 of 20 or 20 over 3. If this is 20 over 3, dito sa kabila is 2/3 of 20, which becomes 13.33. Actually, andito na yan, okay? Minus ka lang dito. Ito naman. This one, take note, this is first degree. Okay? If the load is first degree, the shear is second degree, the moment is third degree. And then the area of that one, area is 1 over n plus what? N plus 1. If this is third degree, the area here becomes 1 over 4. Or 1 over n plus 1, third degree, it's 1 over 4. Okay? Then continue lang. This side is 666.67. Okay? Times 20 na base. Ito na yan. 666.6720. And what is the 16? Here, the centroid for this is 1 over n plus 2 base. Okay? Our degree, okay, is equal to third. So this one is 1 over 20 over 5. Okay? This 20 over 5 is 4. If the total is 20, in other words, the remaining here is 16. Or if this 1 over 5, the remaining here is 4 over 5 of 20. So, as simple as kung 4 ito, remaining is 16. Kaya may 16 dito. And this is being expressed in terms of R. So, by mathematical calculation, okay, yung R na yan, kasi equated naman ito sa 0, makapag-calculate tayo ng R equal to, ano yan? R is equal to 20. So, reaction natin is 20 kilonewton. Okay? Okay, next. What is the location of the maximum deflection? Ito similar to sa kinalculate natin kanina. The location of the maximum deflection is when you draw a line. Ito yung parang kanina din. You draw a line here, a horizontal line, meaning this line has a slope m. Yung m slope ang ibig sabihin. Ano? Or slope is equal to 0. And makakompute natin yung value of x. So what is this angle B and angle CB? Ano yung angle CB na yan? The angle CB, how are you going to calculate that one? Is that just the area of diagram, area moment, from B to C. Asan yan? Kinalculate natin yung B to C. Okay. So, lagay natin dito. Let us draw. So, earlier, we already calculated here the reaction. The reaction is equal to 20. So, this one is 20x, right? So, if this is x, this is y. How do we get the relationship of y and x? Ito meron dito, ilan ba? What's the load of 10? This is 10 kilonewton meter. Okay? This is 10 kilonewton meter. Okay. So what is this value? If you have here, this is 10, right? This is 10. 10 is to 20. And then you have here, y is to x. Asan yung y? Ito y is to x. This big triangle is proportional to this small triangle. So we can have here y, okay, with respect to x. X over 2. Okay, so we can compute this side. Kasi we are looking after this area. Ano? We are looking after this area. So what is this resultant load coming here? It's just the area of the triangle 1/2 yx. What is this 1/2 yx? Okay. That r. Sabihin natin itong r. What is that r? R is just 1/2 yx is 1/2. What is y? X over 2. And what is x? Yeah, it's x. So therefore, this is x squared over 4. So what is this moment here? The moment na to, it's just r, yung r natin, multiply by, what is this distance? Kung x, if this one is x, the location of that one is just x over 3. Okay? So this one is r x over 3. We already have calculated before r is just equal to x squared over 4. And then you multiply by x over 3. In other words, we can have this one as x cubed over 12. This is the value of this moment. Okay. Sa taas naman, 20x. Bakit kailangan natin to? Because we're going to compute yung angle. Okay? Just like yung compute natin kanina. Ano yung angle na yan? Angle or the rotation, ito, CB. The rotation CB or from C to B. Pero dito, pag nagko-compute tayo ng angle, di na kailangan ng centroid. Okay? So what is that one? 1 over EI, this area first, dito sa taas. 1 over EI multiply by, antong area dito sa taas, area lang ng triangle. Okay? This is x, ano? 1/2 20x, and then you have the base is equal to x. Hindi na natin kailangan ng centroid kasi rotation lang. Pagka deviation, kasama siya. Minus kasi ito dito sa baba, minus to kasi ito yung sa Cartesian coordinate system, ito yung 0, ano? Yung x-axis. So pababa, lahat dito pababa, negative. So ano naman yan? What degree is this one? This is first, this is third degree, di ba? First, yung load, shear is second degree. Yung moment is third degree. And then the area is just 1 over n plus 1. So if that is 3, it follows that the area is 1 over 4 kasi n plus 1, 3 plus 1. Ano yung itong side na to is x cubed over 12. And then you have the base is equal to x. Tama? Okay, so we can simplify further. We can have here 20 divided 2 is 10. So you have here 10x squared over EI. Oh, labas muna natin yung EI. Minus x to the power of 4. Okay. All over 4 times 12, 24, 48. Okay. All over EI or times 1 over EI. So meron na tayo nito. Ang purpose natin ito is to compute for the value of x. Kasi pag makompute natin yung value of x, makompute natin yung maximum deflection. Kasi dyan yung x na sinasabi natin na nakapag-create tayo nitong line, na horizontal line na slope of 0. Pag slope of 0, sa sag, dyan yung pinaka-maximum na sag or maximum na ito, deflection. We can have another relationship. Ito namang angle CB. Angle CB, angle B. Okay? From here. Itong angle B dito. Angle B. In other words, ito, ang angle B is yung total na area nito, walang centroid. So, pwede natin makompute dito ang angle B. Okay? Ano itong angle B? Itong deviation na to, Itong deviation na to, you just have to remove itong mga centroids, makakompute na natin ang kuhan. Makakompute na natin ang angle. Okay, from here, 1 over EI, 1/2, ano yung, you have 20, ano yung R? Na-compute na natin earlier, yeah, it's 20. 20R. And then multiply natin ng distance ito. Yung distance dito is 20. Pero hindi na natin, we're not going to multiply the centroid. Okay? Minus 1/4. Ito na. 666.67. Okay, or 666 0.67 multiply by ito. Ito actually, ito lang yung 20. Okay? So, meron tayo dito makukompute na angle of rotation at B. Yung dito. Angle rotation of B na equal to 666.65. 666.65 over EI. Now, I'll show you the relationship of that. Actually, ito na yung pinakita ko sa inyo. Okay. Ito na yung kinompute natin kanina. This one, 10x squared minus x to the power 4 over 48 AI. Ito na yun, na kinompute natin kanina. Now, we have this relationship. Pinakita ko lang dito ang pag-calculate. Ayan na yan para malinaw sa calculation. Ito na yan, Ito yung pinapakita ko na relationship na this, lakihan ko konti dito. Okay. Ito yung elastic curve. Ito yung elastic curve. Similar din ito sa kanina. Ito yung point ng maximum deflection. Andito yung horizontal line. Okay. And dito naman yung point B. Pagka nang draw tayo ng tangent line dito, pupunta yan doon. Okay. This is the angle B. And ito naman yung angle CB. Sa mathematics, laging sinasabi natin na okay, ito. One line, if this angle, X, is also similar, is the same with this angle. So, kung angle B na to, ito yung kinumpit na natin, ano, na ito na yung angle B, na kinumpit natin ang area moment diagram, itong kabuuan. Okay. That's the angle B. And then, this is equal to angle CB. Itong angle CB naman, ito yung kinumpit natin kanina, na from here, ito lang, ito lang to the location of the maximum deflection na X. Ito na yung calculation na yan, actually. Ito yan, ito yan yung location na X. So if we equate angle B and angle CB, kasi nga sinasabi natin na this angle is equal to angle CB. So we can equate that one. Earlier, we calculated angle B as 666.65. Then angle CB with this equation, ito na yan. Then when we equate this the two values, then you can come up with this equation with respect to X. And from further calculation, pwede nyo naman gamitin yung calculator. You can assume A is equal to X squared. A quadratic equation, you can get the value of A. And since we assume that A is equal to X squared, so we can compute the value of X squared. In other words, X is equal to 8.94. Pagka na-compute na natin yung 8.94, madali na natin ma-compute yung deflection. Okay? Okay. Madali natin ma-compute yung deflection. Ano na yung deflection? So, just have to calculate now itong ito na, angle C. Kakalculate na natin yung angle C. Kopyahin ko lang ito. Okay, so sinubstitute na natin, okay, yung value ng 8.94, okay, you have here RA is equal to, kinalculate natin 20. 20 times 8.94, naging 178.8. Ito naman, may 894 na, meron na tayong value kanina. This is x to the power of, this point is x cubed to the power, x to the power of 3, x cubed over 12. Ito na yan. So, may value na tayo dito. And then we calculate the centroid here. The centroid here, this is, if this one is 1/3, ito naman sa kabila is 2/3. Kaya 2/3 dito of 8.94, may 5.96 dito. Ito naman, if this is 3rd degree, okay, 3rd degree. Ang centroid dito is 1 over n plus 2. Kaya maging 1/5 yan. Kung 1/5 dito, 1/5 of 8.94, ang remaining dito, from here, going here, remaining is 4 over 5 or 4/5 of 8.94. Kaya may 7.152. So we can calculate here. Ito, makalculate na natin ang deviation. What's this deviation? C from A. Kasi pagka makalculate natin deviation C from A, meron naman tayong, we can compare now the triangle. Okay, wait. Ano pa ko na mas madali na, okay. We can have the similar triangle. But looking at here, pwede rin deviation B from C. Asan yung deviation B from C? B coming from C. Ito, pagka itong line na to, take note, the elastic curve is here. Deviation at B from C. Asan yung C? Ito yung point ng C dito eh. Is just equal to deflection C. Ano yung deflection na C? That is the location of the maximum deflection. Bakit? This is the location by which X is equal to 8.94, the location by which the slope, this line is equal to 0. Yung kinalculate na natin. So, ibig sabihin, pagka kinumpute mo lang tong area, multiply by its centroid, makakalculate mo na yung deflection. Okay? Pwede rin itong deviation at C from A, pero mas mapapahaba yung calculation natin ng deflection. Kasi, kukompute pa natin itong mag-create pa tayo ng similar triangles, ratio and proportion. Samantala, looking at this area, itong side na to, deviation at B coming from A, ito yung line na kinoconsider natin, itong tangent line. Deviation at B coming from C, yan na mismo yung deflection ng C. That's the deflection C itself. So, how are we going to calculate now? So, area lang, itong area lang, multiply by its centroid. So, that becomes 1 over EI. First, ano yung area? Yung sa taas, 1/2. This side is 178.8. And then, multiply by itong side na to is 8.94. Okay. And then the centroid is 5.96. Kinalculate na earlier. Okay, and then, you have the area here, dito sa baba, minus, ano na yan? This third degree, the area is n plus 1. So 1/4. This side is 59.54 times itong side na to. This side is 8.94. And then, multiply by the centroid. Ito na yung kinalculate natin na centroid. 7.152. Okay, from here, AI pala to. You can calculate now. We can determine the deflection at C. The maximum deflection, which is 3812 EI. Check nyo na lang, no? Kung tama. Okay? So, any question? Okay lang ba? Malinaw naman. Kindly confirm thumbs up kung naintindihan nyo. Hello, naintindihan nyo ba? May tanong? Andiyan pa ba kayo? Pwede naman kayo mag-thumbs up. Okay, that's good. Okay, another one. We have this one. Similar lang din ito. Ito, siya, retaining wall. Ano? Ginawang retaining wall. Pero ang approach niya is just similar to what we did last previous. So here, you have a 6-meter cantilever retaining wall with an active pressure which varies from 0, dito sa taas is 0, and then 35 kilonewton dito sa baba. We assume EI is constant. Ibig sabihin, yung section ng retaining wall, materials the same. Walang pagbabago. Compute the maximum shear first. Ito, madali lang nito. Maximum shear is just the number 1, maximum shear. Asan yan? Maximum shear dito. Ano? It's just the area of the triangle. It's just 1/2 times 35 kilonewton over meter times 6. So that becomes kilonewton. So, ang sagot niyan? Check. Okay, this is 105 kilonewton. Okay, 105 kilonewton. Number 2, what is the maximum moment? Ito. Kung ito yan yung resultant na lateral pressure na actually 105. ito naman yung shear actually pag ganun, opposing. Multiply nyo lang ng moment arm. So if this is 6 meters, this is just 1/3 of 6. Okay, this is 2. So maximum moment is just 105 times 2. Okay. It's 210 kilonewton meter. Okay. Now, third question, if the wall is laterally supported at the free end, kung ito dito may support daw. Okay? Ditong direction ng load nito, so ang support nito is here, ano? Kung may support daw siya sa free end, so magiging parang prop beam na to, maging prop beam na to pagka if we are going to rotate the wall, that becomes a prop beam. So what will be the wall is laterally supported at the free end and fixed at the base, determine the moment at the foundation. So pagka rotate natin, ganito mangyari niyan. Okay? So we compute the deviation. We draw here, coming from here, the moment, ganito mangyari niyan. R times 6 is 6R. Then you have here, this is just 1/2 of 35 times 6. And then here is 6/3. Okay, yung 210 na. So deviation at A from B, if we're going to draw the elastic curve, ang mangyayari ng elastic curve nito, ganon, di ba? Ganon. So if we draw a line, tangent at point A, ganon siya. So the deviation at, it's a deviation at B coming from A is equal to 0. Ito, baliktad to. Deviation at B, okay, coming from A is equal to 0. Kasi ang deviation at A coming from B, ganon yan. Okay, hindi yan 0. It's division at B coming from is equal to 0. So area lang. Area nito sa taas, 1/6R times 6. And then yung 4. Kasi starting from B yung deviation natin. And then ito din area. If this third degree, the area becomes 1/4. And then the centroid coming from here is 4/5. The same din sa problem natin earlier. Then we can compute R. If we could compute R, if R is equal to 21, ito is 21, then it's easy for us now to, kung 21 ito, it's easy for us now to compute the moment at the fixed end support. Kasi moment dito is ito lang, ano? This is the moment. So what is the moment? 21 times 6 is positive, and then minus 35 times 6/2. Actually, that is just the area of this triangular load. 1/2 of 35 times 6. And then you have the centroid, which is this one, 6/3. You can have this value of the moment at the fixed end. Okay, so I want you to try to solve this activity. I want you to visit, please, the classroom. Okay, so this activity is just similar to the previous example earlier. So first we are going to compute the design moment. Okay. Okay, so we are 9-meter high retaining wall, laterally supported at the top. So meaning there's a support at the top and then fixed at the base. The wall resists active earth pressure increasing from 0 here and then 50 at the base. So first, compute the design moment at the base. So this is just similar to our example earlier. As you can see here, this type of problem was given 2011 and then sa 2013 binigay din ulit. Similar to this one. Okay, so by rotating this beam, that makes sense for a prop type beam. Okay, fixed dito. So pagka-tick moment ka dito, 9 times R or R times 9, then ito naman yung moment dito, 1/2 of 52 times 9, that becomes the resultant, and then the moment arm na 9 over 3, 1/3 of 9. So from here, deviation, ito mag-create ka ng ganito. So deviation at B from A, ito yan. Deviation at B from A, we can compute R, and then we can compute moment. I don't know if you all get it correctly. We can check later. Pero the same lang talaga siya. Okay? Right. The second question is to design, compute the design moment at the base when the top support was removed. So kung tinanggal na yung support sa taas, so magiging ko na lang siya, determinate type of beam. Okay? So compute mo lang yung P na, ito yung P is just the area of this load, 1/2 of 52 times 9. Then yung P, multiply mo ng moment arm, makakompute mo yung moment. Base shear is just equal to P na equal to 234. Okay, so I think that one was just easy. Okay, gusto niyo ba mag-dinner? O nag-dinner na kayo? We can continue after 10 minutes if you would like to have dinner or snack. Okay. Okay, so we'll move to 3-moment equation. This method could also be used for indeterminate type of beams, mostly for toe spans beams, auto spans or continuous beam, or even for fixed end type of a beam or prop type prop beam. But for the sake of the board exam, it's up to you to it will be up to you to choose what method you are going to use. Area moment method and the double integration method, I think, is sufficient to use for a determinate type of structure or indeterminate beam. Also, the concept of a 3-moment equation, let's say you have here the two spans of the beam, you have your H1 here, you have here, of course, here the H1 or the height one due to the application of load. There's the elastic curve. You have your L1, L2, and then you have different two types of load here, uniform load, and then you have here concentrated load. You have the formula for you to remember. First, you have here M1 multiplied by L1. So this is M1. Okay, here is M1, and then you have your L1. Then twice of MB or 2MB should be plus 2MB or twice here, the moment here, multiply by L1 and then L2. Sum of L1 and then L2. You have your L1 and then L2. And then the other support, the last support, you have moment C and then multiply by L2. Plus 6A1A, this 6A1A, okay, is being derived from the area moment diagram. Okay, 6A1AL. A1 with respect to the length or the span 1. A2 with respect to span 2. A is coming from the left, B is coming from the right. But you just have to use formula for a common type of loading. Now, in this case, since we can simplify further, since each one and each two supports, meaning there is no settlement or there's no deflection. So we can, okay, wait, I'll just have to charge my laptop. Okay, so we can have, okay, this one could be equals to 0. Okay, so the general formula for this is you only have M1 plus 2MB, L1 plus L2, and then MC times L2 plus 6A1A over L, and then 6A2B over L. How do you get the value of 6A1A over L and 6A2B over L? So you have this one. For example, you have concentrated load. A is coming from the left, and then B is from the right. 1, because it's for the span 1, and 2, it's for the span 2. For example, this one, if you're going to consider this uniform load, you're going to use 6A1A because it's coming from the span 1. And if you're going to consider this L2, you have to use this one. Okay. So in this type of loading, for 6A1A over L, you have this formula. Just for you to remember, P times A, because it's coming from A, so it's P times A, and then multiply L squared minus A squared over L. So if you use A, you use A also here. If you are going in the 6A to B, in the right, you have PB, L squared B. So it's all consistent for B. Now it will be easier for uniform load because you have the same values for 6A1A and 6A2B over L. You have WL cube over 4. Most common naman kasi during the 3-moment equation, yung mga loading type of loads, uniform load lang at saka concentrated load. In other words, these are just the most common formula that you have to remember. So, hindi man masyado maglalagay dyan ng mga varying load. Ano? For the sake of the board exam, masyadong complicated na yung type na medyo haba. Anyway, if you have this varying load, ito lang naman i-memorize nyo. So just have to take note, when you have 6A1A dito sa left, the first span, you are going to consider A, 8 over 60. 8 over 60. Dito naman sa kabila, sa malaki, 7 over 60. Dito sa side na to na may value ng W. Dito sa may value ng 0, 8 over 60. So, similarly here, pagka nagkabaliktad yung load, babaliktad din. Yung 61 magiging 7 over 60. Ano? Dito sa 0, magiging 62B, magiging 8 over 60. Just have to, and memorizing formula, just have to make some hint for you to easily recall the formula. So for example tayo, you have here a continuous beam carries following loads as shown in the figure. So in this case, you're going to use, kung wala itong fixed, madali na to kasi ang mangyayari niyan, yung moment A 0, moment C 0. But in this case, there's a moment value of moment A, there's a value of moment A, and then you also have value of moment B. In other words, you have two unknowns. If you're going to compute for the moment, you have two unknowns. So meaning you have to come up with two equations. So dapat may simultaneous equations kayo na gagawin. So in this case, ang gagawin niya is dapat mag-generate ka ng imaginary span. So parang gagawa ka dito ng span. And then you have your support. Magiging, sabihin natin Li. Okay? Li, then you have your support at I. So from the formula, you consider first this span, this one, and then this one for the first equation. And the second equation, this one, and then this one. So the first equation, for example, in this case, the formula, okay, moment I times Li. Okay? And then twice of, yung pinakikita dito is moment A. Twice of moment A, okay, plus Li, imaginary, and then itong span na to, ito, 4 meters. Okay? And then plus moment B, yung pinakalas na moment, multiply by 4. Plus 6A1A, imaginary man yan, di 0 na dyan. And then 6A2B over L, ang value ng uniform load is W L cube over 4. Ano kung maalala nyo? is WL cube over 4. Ano? Pagka ito. Pagka uniform load. Okay? So, ito yan actually. Ano? Ang value ng ito yung I, ito yung 4 meters. First span 1 and then second span 2. 6E1A L1 is 0 kasi imaginary siya. 6E2B WL cube over 4, ito na yan yung uniformly distributed load na may value na 192. Pagka sinubstitute na natin, ito yung imaginary na sinasabi ko, 0 na to siya. Itong L1 is 0. Yung L2 given naman na 4. Ayan yung 4. Okay? And then 6A1A L1, 0 siya. 6A2B L2, ito yan yung kinumpit na natin na y92. So we have here equation 1. Okay? But we can still further this one. Pwede pa natin simplify. Divide both sides by 4. So that becomes 2MA, okay, plus MB plus ang dinivide natin 4, no? 192 divide 4, that becomes 48. No? Ito na ngayon yung magiging equation 1 ninyo. For you to compute MA and MB, you should need 2 equations. Kaya from that, gagawa na naman tayo ng equation ng okay. Ito naman dito. Ito naman gagawin natin 1, span 1, ito naman gagawin span 2. Okay? Actually, ito na yan, ano? Okay? Ito na yan. Okay. Ito, ang 6, have to remember, 6E2 dito, 6E2B over L. Ito yung formula na yan. Ito, ano? 6E2B over L is PB. Okay. PB L squared minus B squared over L. Tama ba? Okay. PB L squared minus B squared. Asan yung B dito? Ito yung B natin. Okay, ito yung B. Ito yung A. In this case, regardless kung anong nyo sa A or B, wala problema kasi nasa mid-span siya. So A and B are the same. So ano ba, substitute natin. P is 20, B is 3 meters, L is 6 meters squared is 36, minus B squared, or 3 squared is 9, all over, what is the span? 6. So anong value nito? Okay, 20 times 3 times 9 equals divide 6. So it's 270. Ano? 270 ito. Okay? Ayan. Ito na yan. 270 na kinumpute natin. Okay, so out of here, makapag-calculate na tayo. Ano? Ito, consider natin 1 at saka to, no? So first, MA L1. Ano yung L1 natin is 4. And then twice of yung gitna na moment, twice of MB. And then yung sum ng span. Ng spans, L1 at L2, ito 4 and 6. So you have 4 and then 6. And then you have yung last moment doon, MC times yung second span na 6. Okay? And then plus 6A1 L1. Ito ang 6A1 L1 nito. 1 lang naman, parehas lang naman. Ito yan, no? Ito, 192, ano? 192. 192. And then 6A2B, ito na, kinumpute na natin, 270. Equals to 0. Okay, so you have here 4MA. And then this one, 4 plus 6 is 10 times 2, becomes 20 MB. Plus, moment siya actually here, moment here is 0 kasi hinge support. 0 na yan. And then you have 192 plus 270. 192 plus 270. Ayan na yung 462. Pwede natin i-divide din to ng para maging equal dito, ano? Pwede din na divide natin ng 2 para maging 2MA siya. 2MA plus 10MB plus 462 divide to 231. Kasi from here, okay, equation 2, using yung calculator, 2 equations to anon, makompute nyo na yung MA at saka MB. Ito na yan, ano? Ang ginawa niya dito, ito naman, no? Ginawa niyang 4MA lahat. Okay? Dito, MA, yung kinalculate natin kaya na 4MA, 20MB plus 462. Ito yan, no? 4MA plus 20MB, 462. Yung equation 1, minultiply ng 20 para magparehas siya. Okay. So, kung anong method man ang gagawin nyo, to equations to unknowns lang yan, makakapag-calculate tayo ng MA at saka MB. Okay? Kung anong method yan. Dito pa lang, pwede na kayo mag-calculate using calculator. Ma-calculate na, you can calculate now here MA and then MB. The problem here is just to calculate the M moments. The moments. Moment at A and moment at B. Okay, the question is to compute for moment at A, moment at B, and then reaction at C. Pagka may moment A, moment B na, madali na mag-compute ng reaction C. Okay? Paano pag-calculate? Sige, tuloy natin para makita nyo. So, halimbawa, you have here, this is the beam. Fixed ito. Ito yung load na yung load? 12 kilonewton meter. This is 12 kilonewton meter. At ito yung fixed. May moment A dito na ito yung A. Ito yung moment na 13.83. Okay, what about moment B? Diba pinakita ko yung moment B? Okay. So we can calculate here. Pagka may moment A na, you can calculate also moment B. So andito yung moment B. And then you have here the load na 20 kilonewton. This is may reaction dito na RA. Meron din reaction dito na RB. Meron din dito reaction na RC. This is 4 meter. This is 4. This is 6. Kasi 3 ito. This 3 ito. By the way, what's the value of your moment B? Let's check. I have here, if we are going to substitute negative 13.83, okay, substitute natin dito sa dito na lang, okay, plus MB plus 48 equals to 0. So dito pa lang makakompute na natin yung MB. Okay, so you have 13.83 times 2, negative 37. Okay, and then it's negative. So moment here will become positive. Negative, I should say, 20.34. Okay, so this one is 13, it's 20 times this 26 something. Negative, ito naman positive. Transpose will become negative. Negative 20.34. Okay. So papunta dito yung negative. Ganon din. So how can you compute the reaction here? Isolate nyo lang to. What's the question? Compute for reaction C. Isolate lang natin ito. Isolate lang natin to. So, lagyan natin dito. Okay. Meron ditong 26. 26 ba? 20. Okay. Meron ditong RC. Meron ditong moment na negative. So, ang moment dito is pag ganun. I think 20.34. Okay. This is 3. This is 3. Okay. So, moment C. Ito, mayroon dito reaction at B. Okay. So, this is moment C. Taking moment at, no, moment B, I should say. This is B. This is C. Summation moment at C equals to 0. Ganito lang, clockwise is equal to counterclockwise. Ano yung clockwise dito? Ano yung mga clockwise? Ito, 20.34. Kasi consider natin na pag ganito, ano? And then you have plus RC times 6 is equal to 20 times ito, 3. Ano? 20 times 3. So what is RC? 20 times 3 is 60 minus yung 20.34 is equal to 39.66 divide 6. So, ibig sabihin yung RC is 6.61 kilonewton. Kung RC 6.61, RB, madali na ma-compute. This is just 20 minus RC. Okay, so you have your RB is equal to 13.39. Okay. Madali na rin ma-compute yung RA kasi ang total load is 20. Okay, 20 ito plus 12 times 4. Ito, resultant load here is 12 times 4. Okay, so you can just have, ito, you just have to sum of vertical forces. RA plus RB plus RC is equal to, ito ano, 20 plus, ito naman, 12 times 4, 48. Okay? So kung na-compute nyo na yung RC, ito na na-compute natin, RB ito na rin, so we can compute also RA. Okay? Any question? Any question by the way? Wala bang tanong? Wala na yata ako estudyante. Isa na lang ng thumbs up. Anyway, yung next na ako natin, let me share. Okay? Okay, wait. So the next topic is influence lines, okay? That would be influence lines. Okay, our next topic is influence lines. I think continue lang tayo next time meeting muna, okay? Not unless you have questions. Okay, if you have no questions, we'll continue next week.
Sige sir. Salamat po.
Okay, welcome.
Okay po, thank you po.
Okay, next time na lang. By the way, meron doon isang activity. Anyway, that's all about influence line. Okay, we'll just continue next time.
Okay po.
Okay, bye-bye.
Sige po. Salamat po.
Sir, thank you, Sir Jim.
Okay, bye. Welcome.
Oh, thank you po.